Hello everyone. Welcome to the solution of LeetCode problem 1466 named Reorder routes to make all paths lead to city 0. In this problem, there are n cities numbered from 0 to n-1 and n-minus road such that there is only one way travel between two different cities. Now last year, the Minister of Transport decided to orient the road in one direction because they are too narrow. Now, the roads are represented by a connection array where each element is a pair of A and B. That means there is a road from the city A to city B. Now, this year, there will be a big event in the capital at city 0. Now, many people want to travel to this city. Now, your task is to reorder some road such that each city can visit the city 0. And we have to return the minimum number of edges changed. And it is guaranteed that each city can reach city 0 after reorder. Now let's consider this first example. This is city 0, which is connected to the city 1, and 1 is connected to 3, and the city 2 is connected to the city 3, the city 4 is connected to city 0, and the city 4 is connected to city 5. Now, if we reverse this road, which is 0, 1, 1, 3, and 5, 4, we can reach to city 0 from any numbers of different cities. So here we have to reorder 3 roads such that we can reach city 0 from any of the cities. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken the same example. At first, we have to understand that this problem can be solved using the DFS technique. And basically, it is a graph traversal problem. And the problem is we are given a detected graph which is complete. That means this graph does not have any of the cycle and it is connected. And here we have to reorder some of the edges such that all of the node can reach to the node 0. Here we can see that if we reorder this edge from 1 to 0, if we reorder this edge from 3 to 1, and if we reorder this edge from 5 to 4, from any of the node, we can reach to the destination 0. So now the question is, how can we basically solve this problem? This is a pretty straightforward DFS problem, but understanding the solution can be a little bit of tricky. Now let's see how can we solve it. As our destination is in the city 0, so we have to start the DFS from the city 0. Now from city 0, we have to check its neighbors such that how many neighbors can reach to city 0. So here it has 2 neighbors, 1 and 4. So from city 0, we can go to 1. So this is an outgoing edge. That means we have to reorder this edge such that 1 can reach to 0. But in the edge 0 to 4, or it is 4 to 0, it is inwards or incoming edge. So we don't have to reorder this edge. Now this is the first edge we have to reorder. Now we have completed these 2 neighbors. Now our target is for these neighbors, how many of them can reach to the level 2 or these neighbors. Here, if these level 2 nodes can reach in the level 1, we have already reordered the level 1 edges. So from the level 1, we can easily reach to level 0. Now, our target is how many of the nodes we can reach into the level 1. So this is the outgoing edge. So we have to reorder this edge. So it is the second edge. Now, again, this is the outgoing edge from 4 to 5. So again, we have to reorder it. So it is the third number edges. Now we have to search for the next level, which is 4. Sorry, which is 2. So we have seen that for this edge 2 to 3, it is incoming edge for the node 3. So we don't have to reorder this. So far, we have seen that we have to reorder 3 of the edges. One is this, another is this, and another is this. So suppose if we come from 5 to 4, then obviously we can come from 4 to 0. So that means by using the DFS in this manner, we can solve this problem. But the question is, how can we implement it? As it is a pure depth first search problem, we have to take our adjacency list and the visited array to run the DFS. Now, let's build the adjacency list. For this edge 0 to 1, we have to insert 1 in the adjacency list of 0. So here, basically, it is a positive value 1. That means that it is an outgoing edges from the node 0. Now again, we have to insert minus 0, or basically minus 0 does not means anything. We have to insert 0 in the adjacency list of 1. This is the trickiest way to build the adjacency list. Now, for this edge 1 to 3, we have to insert 3 in the adjacency list of 1, and we have to insert minus 1 at the adjacency list of 3. This connection, basically 3 and minus 1, depicts that this is the imaginary connection, or that means this negative connection basically denotes the incoming connection from 3 to 1. But as there is no connection in the original graph 3 to 1, so we have to insert minus 1 in the adjacency list of 3. Now, for this edge 2 to 3, we have to insert 3 in the adjacency list of 2, and we have to insert minus 2 in the adjacency list of 3. Now, for this edge 4 to 0, we have to insert 0 in the adjacency list of 4, and we have to insert minus 4 in the adjacency list of 0. For this 4 to 5, we have to insert 5 in the adjacency list of 4, and we have to insert minus 4 in the adjacency list of 5. So far, we have built the adjacency matrix. Now let's start the DFS. Initially, we are at this root node 0. From 0, we can go 1. But before going to 1, let's make the visited 1 true. Sorry, visited 0 true. Now, from 0, we are at this point 1. So we have seen that for this 0, its children is 1 and it is positive. That means positive children basically means there is an outgoing edge from the node 0. So we have to reverse this edge. So this connection should be altered. Now from 1, we can go to 0. 0 is already visited. And from 1, we can go to 3. So here, this 3 is a positive value. This basically means that we have to reverse the edge. That this positive value basically means that there is a outgoing edge from 1 to 3. So we have to reverse it. From 3, we can go to 1, but 1 is visited. We can go -2. So here 2 is not visited, so let's make the visited 2. This -2 basically represents that there is an incoming edge. So we don't have to do anything here. Now from 2, we can go to 3. 3 is already visited. Now from 1, we can go to -4. Or from 0, we can go to -4. So here, -4 basically represents that there is an incoming edge, so we don't have to do anything. So let's make 4 visited. Now from 4, we can go 0 and 5. 0 is already visited, and let's make the 5 visited. So here, for this 5, it is a positive value. That means there is an outgoing edge from 4. So we have to reverse this edge. So here, from 5, we can go to -4. That means there is already a reversed edge. So here, after that completion of this DFS algorithm, we have seen that we have found in total of 3 edges such that we have to reverse it to reach into the destination 0. And this is how the algorithm works. The overall time complexity of this algorithm is big O of n. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named mean reorder, which is integer n and vector of edges. Now we are taking adjacency list and the visited array. Now for each of the edges, we are storing the forward edge and the backward edge. And we are calling the DFS from the node 0. Now, inside the DFS function, we have to make the node visited. And for each of the children, if the absolute value of children is not visited and the children value is greater than 0, that means it is an outgoing edge. So we have to reverse this edge. So we have to increment the counter. After that, we have to recursively call the DFS function into the children with the same adjacency list and visited array. Finally, we have to return the counter. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.